So today we're going to be wrapping up Graphing Quadratics, and we're going to essentially today put together everything that we've learned. So we're going to have stretch, we're going to have compress, and we're going to have reflection and up and down. So just an overview again, see what you're adding. That's what causes your graph to move up or down. A, that reflects the graph, and that happens when A is negative. And then A also stretches or compresses the graph. So when it stretches, that means it's getting skinnier. And it can be up or down. And when it compresses, it's getting wider. All compared to the parent function, which again is just y equals x squared. And so we can tell from our A value whether it's going to stretch or compress. So when A is greater than 1, then my graph is stretching, we're getting more narrow, we're skinnier. When it's between 0 and 1, then the graph is compressing, or getting wider. And a compression is when A is a fraction between 0 and 1. So we kind of talked about that last time. That means that the smaller number is on top, and the big number is on bottom. So if it's the other way around, then that's really going to be a fraction greater than 1. So let's look at this first example. So I want to graph the function and then compare it to the parent function. So I want to first go ahead and just put my parent function on here so that we can easily compare it. So my first step when I want to graph this is I need to find my vertex. And so remember, we get our x value with the formula negative b over 2a. So I'm going to first just write what my a, b, and c are. My a is that number in front of x squared, so in this case negative 2. I don't have an x term here, so that means my b is just 0. And then my c here is negative 3. So plugging those into here, I have negative 0 since my b is 0. Over 2 times a, well a is just negative 2. So I have 0 over 2 times negative 2 is just negative 4. And then 0 divided by negative 4 is 0. So I know my vertex, that first coordinate is going to be 0. And then to find my y value, I need to plug 0 back into this function. So I want to have f of 0 now, which again, that's really the same thing, it's just y, is equal to negative 2, and now 0 squared, minus 3. Well, 0 squared is just 0, times negative 2 again is 0, so I have 0 minus 3. And so I get negative 3. So that means my vertex is at 0, negative 3. And then my next step is I need to put this into a table and find some other points. And so my vertex is just going to go into the middle. And then I'm going to put 2 points above and below 0. So I'm just going to do negative 1, negative 2, 1 and 2. And then to find my y value, which again is just the same thing as f of x, I'm going to plug those values into my function. So starting at negative 2, and I plug that in, negative 2 squared is just 4, because negative 2 times negative 2 is 4. 4 times negative 2 is negative 8, and then negative 8 minus 3, I get minus 11. Doing the same thing with negative 1 now. I do negative 1 squared, because remember with our operations, order of operations, we want to do the exponent first. So negative 1 squared is just 1, times negative 2 is negative 2. Then negative 2 minus 3, I get negative 5. And if you remember from our pattern here, I want these numbers to be the same thing, but we're going to go ahead and plug it in and make sure that happens. So now I have a 1 going into here. 1 squared is just 1. Negative 2 times 1 is negative 2. minus 3, and I get minus 5. And then plugging in 2 into here. 2 squared is 4. 4 times negative 2 is negative 8. Minus 3, and I get minus 11. So I say I do have my pattern, which I want. And that's a good way to check yourself. So here I have my points, negative 2, negative 11, negative 1, negative 5, 0, minus 3, 1, negative 5, and 2, negative 11. So plotting those points onto here, starting my vertex, I have minus 3. And then I have negative 1, negative 5, and 1, negative 5. And then negative 2, negative 11, and then positive 2, negative 11. And so I see I get a graph that looks like this. And then now for my last step, I want to compare this to the parent function. So first off, I notice from my 2 vertices here, my vertex went down 3. And again, I can always get that from my C value here. So I went down 3. And then from my negative 2 here, or just from the 2, that tells me whether I stretched or compressed. And we see from our previous slide, when A is bigger than 1, then the graph is stretching. So I say this stretched by 2. And then the last thing I notice is that my graph kind of flipped over, and we call that a reflection. And I can automatically tell that it's going to do that because of this negative right here. Since this A is negative, I can say this reflected. And so that would be my answer to how I'm comparing it to the parent function. Okay, let's try one more, and this time we have a fraction. So again, I'm going to start with just putting my parent function on here. Next, I need to find my vertex. So here my A is 1/2, or negative 1/2. My B again is 0, and C is equal to 3. So plugging those in, I have negative 0 over 2 times A, which is negative 1/2. And well, 0 divided by any number is always just going to be 0, so I have x equals 0. So I know my vertex is starting with 0. And then now to get my y value, I'm going to plug that into my function. So I have g of 0, which again, that's the same thing as y, is equal to negative 1/2 times 0 squared, plugging in 0 for x, plus 3. Well, this whole thing just comes out to 0. And then 0 plus 3, and I get 3. So my vertex here is at 0, 3. And then next, I need to put this into a chart so I can get some other points. So I'm going to put my vertex in the middle. And then 2 points above and below my x value here will be negative 1, negative 2, 1, and 2. And then now I'm going to plug those values into this function. So plugging in negative 2, I have negative 2 squared here. Well, negative 2 squared, that's negative 2 times negative 2, and that gets me a positive 4. Times negative 1/2 is going to get me negative 2 plus 3, and I get 1. And then plugging into 1 into here, or negative 1 to here. Negative 1 squared is a positive 1. Times negative 1/2 is negative 1/2. And then negative 1/2 plus 3, that's going to just get me 2.5. Or if you prefer, you can put this as a decimal and do 2.5. And then now again, I know I'm doing it right if these are going to be the same numbers as up here, but we'll go ahead and check and make sure. So when I plug in 1 into here, 1 squared is 1, times negative 1/2 is negative 1/2, plus 3, and I get 2.5 again. And then plugging in 2, 2 squared is 4, times negative 1/2, so half of 4 is negative 2, plus 3, and I get 1. So I get my points, negative 2, 1, negative 1, 2.5, 0, 3, 1, 2.5, and then 2, 1. And so now I'm going to go ahead and plot those points. So starting my vertex, I have 0, 3. At negative 1, I'm at 2.5, so 1, 2, and then halfway. At 1, I'm also at 2.5. And then at negative 2, I'm at 1. And positive 2, I'm at 1. And so now when I graph that, I get this. And so now I need to compare it to this parent function. So first thing I notice is from these vertices, I went up 3, which again I would get from my C value. And then for my A value, since I have a fraction here, it's going to be a compression. Again, that's because my smaller number is over a bigger number. So it's between 0 and 1. So I know I'm compressed by 1/2. And we can see that in the picture. My green graph is wider than my red graph. And then my graph kind of flipped over, and so that means it reflected. And I can tell that also from my equation because I have a negative out in the front. So I'll say this is reflected. And that is it for today. Your homework is on big ideas.